Okay, in this problem we have the improper integral from 0 to infinity of 42 times tan inverse of 3v divided by 1 plus 9v squared dv. Okay, so first thing that we should do in this is write it as a proper integral. So let's write it like this: limit as b approaches infinity, 0 to b, and then let's write that stuff on the inside. Okay. All right, so how we're going to do this problem is we're going to say that u is equal to inverse tangent of 3v. Okay. And that means that du, now it means we're taking the derivative of tangent inverse of 3v. Okay, so that's going to be 3 over 1 plus 3v squared dv. Okay, the 3 comes from the derivative of the inside, so whatever the derivative of the inside of this inverse tangent function is what goes on top, and then on bottom this 3v obviously is from there and it gets squared. Okay, so that will, if we solve that for dv, that will be dv is equal to, we multiply this over, I'm going to go ahead and make that a 9v squared when I move it over. Okay, so it'll be 1 plus 9v squared, and then divide this over, so divided by 3 du. Okay, so I just switch sides. I want the dv by itself, so I multiply by the bottom, divided by the top, and I got it where I want. Okay. The other thing I want to do is change my limits. So if I have u is equal to inverse tangent of 3v, I'm going to plug in the lower limit, so 3 times 0, which is 0. And inverse tangent of 0 is 0. And that's because if you plug in a 0 into tangent, you get a 0 out. Okay, so the inverse tangent of 0 is 0. Okay, and for the other one, we'll have the limit as b approaches infinity of inverse tangent of 3b. Okay, so as inverse tangent approaches infinity, then that's going to approach pi over 2. So we'll say u is equal to pi over 2. Okay, that's this limit. Okay, and if you don't really know why that's the limit, then just look at the tangent function, graph it, and you can see as you approach pi over 2 on the graph of tangent, then it goes to infinity. Okay, which means the inverse of that is true. So inverse tangent of the infinity will be pi over 2. Okay, so those are my two limits. So now I can rewrite the integral from 0 to pi over 2. Okay, and let's see, I've still got the 42 there, here. And then the tan inverse of 3v is my u. Okay, the bottom is 1 plus 9v squared still. And now, in place of dv, I'm going to write all this stuff, because I solved it for dv, so I'll substitute that in. So times 1 plus 9v squared divided by 3 du. Okay, so obviously we got some things that are going to reduce here. So this reduces. Okay, and then 42 divided by 3 is 14. So I get the integral from 0 to pi over 2 of 14u du. Okay, so we integrate that. That's a pretty easy integral. So that gives us 14u squared over 2 from 0 to pi over 2, which is 7u squared from 0 to pi over 2. Okay, and then if you plug that in, let's keep the 7 out front. So you get 7, and then you plug in your upper limit, so that'll be pi over 2 squared minus the lower limit, which is 0 squared. Okay, and 0 obviously goes away, and you get 7 times pi squared over 4. So 7 pi squared over 4 is the answer.